Hello guys, so we're going to be solving question 1 of the June 2023 Gauteng paper that was written on the 9th of June, right, which is the day of the recording. So yeah, let's go. 1.1.1, right? They want us to solve for x from the given equation, right? So let's go write that down. So 1.1.1, we're given 12x is equal to x squared, right? So once we are here, we know that we can just take everything to the other side. So we have x squared here minus 12x, right? And that is going to be equal to 0. And we notice that we can take out a common factor here, so which is x, then minus 12 here, right? So which means that when we have something like this, guys, right, what this means is that this product, right, gives us 0. And we understand that if we can multiply anything with 0, right, we'll get 0, right? So either this has to be 0, then it multiplies with that, making the whole thing 0, or this is 0 multiplying with that, making everything else 0, right? So that's what we have there. So let's go. So 0 is equal to x, or okay, let me write it like this: x minus 12 is equal to 0, right? So which means that x is equal to 12, right? So yeah, it makes sense, because if I can just replace this here, 0 times 12 gives us 0, and 0 squared is still 0. And if I can just place 12 there, 12 times 12 is 144, and 12 squared is also 144. So that's okay. So in the next question, they ask us to say hence or otherwise, right? Determine the values of p, right? If p squared minus 1 all squared is equal to 12 into p squared minus 1, right? Hence or otherwise. So these are the keywords here, right? Meaning that we can use the previous answer that we've just solved, right? So if we look at this, guys, let me just write it down here. 1.1.2, we have it like this. So we have p squared minus 1. This is all squared is equal to 12. P 12, yeah, p minus 1 squared. Yeah, so this is what we have now, guys, right? So if we just compare to the previous question, right, look at this, guys. Let me write it like this: 12, I'm just swapping, right? 12 p squared minus 1 is equals to what? P squared minus 1 all squared, right? So I just swapped this and that, right? So if you look at this, guys, it looks exactly like what we had in the beginning. Can you see we have 12 multiplied by x and x squared? Now we have 12 multiplied by something and that very same thing squared. So when they say hence or otherwise, it means we can use the previous answer, right? So it means that, remember that, guys, this in this case, this represents x. You understand? So now, since that represents x, let's move. So it means that p squared minus 1 is equal to x. But remember, for x, we had two solutions, right? So this therefore means that p squared minus 1 is equal to 0, or p squared minus 1 is equal to 12, right? And yeah, let's solve for this, right? So this is a difference of two squares. We have p minus 1, p plus 1. That's a difference of two squares is equal to 0. Or we have p squared is equal to, this goes that side, this is going to be 13, right? Which therefore renders p as plus minus the root of 13, right? And this means p is equals to 1, or p is equals to negative 1, right? So you can test your answers, put them back into the equation and see that they work, right? So the main key here was just identifying that this looks very similar to our previous question. Hence, they said hence or otherwise solve. You understand? So yeah, when they say hence or otherwise, they implying that we can use the previous answer to help us. You understand? So it's okay. Let's move to the next question. Right, so here now it says 1.2 says solve for x if 5x squared plus 7x minus 2 is equal to 0, and round off the answer to 2 decimals, right? So round off the answer to 2 decimals. That's implying that we should rather use the quadratic formula, right? So we have 5x squared. So let's go. We have 1.2. Let me just change the color. We're at 5x squared minus or plus 7x, I think, plus 2 is equal to 0. Let me just make sure of that. Yes, okay, it's minus 2, right? So yeah, minus 2, right? So what this means is that I'm going to just replace into the quadratic formula, which is given on your formula sheet, right? Which is minus b plus minus the root of b squared, which is your discriminant, minus 4ac, right? So this is just your delta, your discriminant, right? All over 2a, right? So let's just replace our value of b. In this case, this is written in the form ax squared plus bx plus c, right? So which means c is this value here, b is the coefficient of x, and a is the coefficient of x squared, right? So let's just replace that. So we have minus, into brackets, we have 7 plus minus the root of that very 7 squared minus 4 into a. Our a in this case is 5, and our c is negative 2, right? And all that all over 2 into our a, which is 5, right? So just punch in, then you're going to get your first value of x and your second value of x. So let me just get my calculator, right? So which means that x is equals to 0.24, or x is equals to negative 1.64, I believe, right? So this is what we have there. So right, let's go back to the questions. So 1.3 asks us to solve for x if x plus 6 is equal to x, right? The root of x plus 6 is equal to x, right? So in that instance, what they've done for us is they've already isolated, right, the root. So in most of the time, right, or all of the time, when we're dealing with root equations, right, we always want to make sure that we isolate. One of them will be invalid, right? So just make sure you test your answers, especially on the root equations, right? And they've already done one step for us, which is isolating the root, right? Which is very, very important, which is like the first step whenever we're solving such equations, right? So we're going to have x plus 6 here, right, is equal to x, right? So we just always want to make sure that our root, right, is isolated, right? It means it's alone on the left hand side, or either the right hand side of the bracket of the equal sign, I meant to say, and then we can square both sides, right? So let's square both sides, that squared and that squared, which means that this square root is going to be cancelled by that, and then we're going to have x plus 6 is equals to x squared. So now let's write it down in standard form. 0 is equals to what? X squared minus x minus 6, right? So now let's just find the factors. So we understand that we need to find the factors of the last term, right, that give us the middle term. So negative 6, right, we need to find its factors that give us negative 1. So we have negative 3 multiplied by positive 2, which gives us negative 6, and minus 3 plus 2 is indeed minus 1. So those are our factors, right? So we have, in this case, we have x minus 3 and x plus 2, right? So which means, therefore, that x minus x is equals to 3, or x is equals to negative 2. So I just transposed that, right? Because initially what we would have done, we were just going to say x minus 3 is equals to 0, or x plus 2 is equals to 0. So I just took these to the other side, right? So this is what we have here as our answer, negative 2 there, right? So now in root equations, right, there's always an answer that is incorrect, or that is invalid in this case, right? So just make sure that you check it out and see which one actually balances out, right? So let's try and replace 3, right? So if we replace 3 here, it's going to be the root of 3 plus 6, which is the root of 9, which gives us 3. And indeed, it does give us x, because x is 3, which is what we replaced, right? So now let's try replacing negative 2. If we replace negative 2 where x is, we're going to have minus 2 plus 6, the root of that, which is the root of 4, which in this case, we're going to have 2. And then if we put here negative 2 where x is, it does not match, which means that left hand side is not equal to the right hand side when x is equal to negative 2, which means that this is non-applicable, right? So yeah, let's push, right? So now let's go to the next question. Use the solution in question 1.3 to determine the value of y for which, right? So let's write that down. Let's write that down. The value of y for which. So we have, right? So here we have y minus 5. And I believe that here we have y plus 1. Let me just make sure. Yes, the root of y plus 1 is equal to y minus 5. So they ask us to use the previous answer, right? So this question, usually it would range about 5 marks, just like the previous one, right? But now they tell us to use the previous answer. That's why it weighs way less marks, right? So let's go. So let's just understand, let's observe the relationship between these two, right? So they want us to use the previous answer, right? So we could easily solve it, right, without using the previous answer, but in specific, they want us to use the previous answer, right? So what you could do is solve it, right, using the long method, but on the side, right, and then know what your answers are already, right, and then you can try and find the link, right? But in this case, what I see is that we have a root, and then we have values on the right hand side of the bracket, right, on both equations, on the right hand side of the equal sign, on both equations, right? So what we have here, we had square root of x plus 6 is equals to x. And as I observe further, I notice, no man, I had x plus 6. Now I have y plus 1, which means I've gone down by 5 units. And here I just had x. Now I have y minus 5. So it means I've also gone down by 1 unit, right? So it means there's some sort of link. So it's quite safe to say that x, if I was to say x is equals to what? Y over 5, y minus 5 in this case, right? If I was to say x is equals to y minus 5 because it's on the right hand side of the bracket, of the equal sign, which means that y is therefore equal to what? X plus 5, right? Because I just took this to the other side, right? And then, that's what we have there. So now let's push, right? So we have values of x, remember? We have x is equals to 3 and x is equal to negative 2, right? So now y is therefore equals to, what is our x is 3 plus 5, or y is equal to minus 2 plus 5. So which means that y is equals to 3. Here y is equals to 8. So this is how we get it, because we just understand the link between that. You understand what I mean? So we just equate the right hand side, right, to each other. So here we had x, and then here we had y minus 5, right? And I noticed a shift. I see, we come from x plus 6 to y plus 1. So which means we've gone down by 5 units, right? And also on the right hand side, we've gone down by 5 units, right? So I just took what's on the right hand side and equated it to what's on the right hand side of the first equation. So you can even test these answers, right? So this is what we have here. But we understand that obviously this is a root equation, which means that both answers cannot be correct. We only have to have one answer here, right? So what we're going to have to do now is replace it into this formula, right? And you're going to find that, okay, let's try replacing 8. So the root of 8 plus 1, which is the root of 9, right, gives us 3. So 8 minus 5 indeed also gives us 3. So 8 is the correct solution here. Even if you try and replace negative 2, so here we're going to have root of minus, not of negative 2, I mean 3, right? So the root of 3 plus 1, right, which is the root of 4, which is equal to 2. But if I come here, I replace 3 where y is, it's going to be 3 minus 5, which gives me negative 2, which means that is not a solution because the left hand side is not equal to the right hand side, right? So we're done with that one, right? So so we're done with that. So we know that therefore y is equals to 8. This is not applicable, right? So let's move to the next question right here. So now they say a race requires an athlete to run 10 kilometers and cycle 50 kilometers, right? And TENDANI runs at a speed of x kilometers per hour, right? So this is our speed. It's very, very important, right? Because in the question, which is worth 6 marks, they want us to calculate the speed. So in other words, we're trying to solve for x, right? It's okay. So calculate the speed, right? Right. So they say, okay, let me just continue reading. It says TENDANI runs at a speed of x kilometers per hour and cycles at x plus 31 kilometers per hour, and he takes 10 over x hours for the 10-kilometer run, right? So important, right? So that's what we have there, right? So now let's continue. So now what they want from us is to express the time he takes for the 50 kilometers cycle in terms of x, right? So you can look at this as calculus, right? Because it is calculus actually, right? So it's just the application, right, of it's just a real life application. It's like a word problem, right? So we can just view it in that sense, right? So we need to come up with an equation here, right, that expresses the time he takes for the 50 kilometer cycle in terms of x. So for the 50 kilometer cycle, what we have, the information that we have for the 50 kilometer cycle, right, is that first of all, the distance is 50 kilometers and the speed at which he cycles is x plus 31, right? So, but they want us to find the time. But we have what? The distance, which is 50, and we have the speed, which is x plus 31, right? And if you can look at these, right, you can just come up with a relationship, right? That, you know, that what? Distance is equals to speed times time, right? So using this, we can manipulate this and find t, because we have speed and we also have the distance, right? So let's go into it. So now they just want us to express the time that it takes for the 50 kilometers cycle in terms of x. So now let's go, right? Let's go. So let's just change the pen. So now let's go 1.5. I think it's 1.5, right? So this is what we have. So we know that distance, right, is equals to speed multiplied by time, right? It's from this triangle here where we have d, and then we have s here, we have t there, right? So we know the distance, right, is 50 kilometers, and our speed is what? X plus 31, right? And we're looking for the time. So in order to get the time, right, independently, we just need to divide both sides by x plus 31, because it's multiplying with the time, right? So the only way that we can get rid of that, which is multiplying, we divide it, right? So we divide both sides by x plus 31, and this by x plus 31, right? So it means that this is going to cancel that. So it means our time is equals to what? 50 over x plus 31, right? So this is what we have there as our time, right? Expressed there, right? So the next step, right, is to go to the next question, which asks us to calculate the speed, right, corrected to 2 decimal places, at which he must run to complete the entire race in 2 hours. So in other words, guys, they want x because they told us that the speed of whatever he was running is x, right? So they want the value of x, right? So, okay, because we can see that the speed is expressed in terms of x. So they want the speed, right? Which means they want x. So it means whatever equation that we come up has to be in terms of x. But they tell us that to complete the race in 2 hours. So now our equation that we have to come up with, right? First of all, it has to be in terms of x. But now it has to be an equation of time, because they're telling us 2 hours. So look at this, guys. So, and they spoke about the entire race. Look at this. So calculate the speed corrected to 2 decimal places at which he must run to complete the entire race in 2 hours. So we need to find the time that it takes for him, right, in terms of x for the entire race. Because first thing, we get the time that he takes to run the 10-kilometer run, and we also just calculated the time that it takes for him to run the 50-kilometer cycle, right? So now let's just do this, right? So now we have the time 1. Let's just call this time 1, which is 10 over x, which is for the 10-kilometer run. And we also have our second time, which we've just calculated, which is 50 over x plus 1, right? So now they want us to express time in terms of the entire race. So which means that he's gonna run, right? And then he's also gonna do that. So we need to add those times so we can calculate the time, right, that it took for him to run the entire race, right? So let's do this. I'm just gonna say t in terms of x. So t is gonna be representing the time for the entire race, of course, right? So now that's what we have. So we're gonna have 10 over x, right, plus 50 over x plus 1, right? So that's what we have there, right? So this is our function of time. So this is the time that it took to run the entire race. You understand? So now, because it took him 10 over x hours to run the first part of the race, which is the running part, and it took him 5 over x plus 31. I'm sorry about that. It's 31, right? Plus 31, right? I don't know why I wrote. Right, so this is the time, right, for the entire race. But they want us to find the speed, which is x, the speed at which he must run, right? Because remember they told us in the beginning that he was running, right, at a speed of x. So you just want us to calculate the value of x, where the time that it will take him to run the entire race will be 2 hours, right? So let's resume. So now what we have there, we know that our time for the entire race, which we expressed in terms of x, has to be equal to 2. So now let's go. 2 is equal to what? 10 over x, right? Plus 50 over x plus 31, right? So now we just want to solve the value for the value of x. So now one thing we see that we have an equation, first of all, and it has one unknown variable, so which means we're not going to be doing simultaneous equations. So one method that we use, right, we can use to simplify this expression, right, is to use the DDD method, DDD, right, which means we multiply the diagonal, the other diagonal, and then the denominators together. So we're going to have 2 here is equals to what? Our first diagonal, which is 10, multiplied by that, we're going to have 10 into what? X plus 31, right? Plus the other diagonal here, which is x, plus times 50, which is the same thing as 50x. All over the denominators multiplied by each other, we have x into x plus 31, right? So the next thing that we can do now is say 2 is equal to, let's just expand what we have there, right, which is 10x plus 310, right, plus the 50x there, and then we expand the denominator, we're going to have x squared plus 31x, right? So here we have a fraction again, and we just want to get rid of this fraction, so we're going to multiply both sides, right, by that fraction, by the denominator, I meant to say, right? Let's go. So 2 into x squared plus 31x, right, is going to be equal to that, because once we multiply this by x squared plus 31x, right, this is going to cancel that, right? So let's resume. Is equal to what? 10x plus 50. Let me just write it down as 60x. These are like terms. Plus 310, right? So here, if we expand, we're going to have 2x squared plus 62x. And then let's bring everything to the other side. So we can write this in standard form. Minus 60x minus 310 is equal to 0, right? So now what we have there, you can see that we have like terms that we can group here, right? We have like terms here so that we can deal with that. So now let's go. 2x squared plus 2x minus 310, right, is equal to 0. So now we just need to solve for x, right? One thing we can see that, whoa, we have a common factor here of 2. So let's just factor that out. Divide every term by 2. Then we're going to have plus x minus 155, I believe. And then this is equal to 0. And then, of course, here, I don't see any way that we can find the factors of 155 currently at the moment. Maybe there is, but let's just go the safe route. Quadratic formula. X is equal to minus b plus minus root of b squared minus 4ac all over 2a, right? So now our x, right, is here, and then our b, of course, is going to be our invisible 1 there, right? Minus 1, right, into plus minus the root, right, of 1 squared minus 4. Our a value is also 1 into 1. Our c value in this case is a negative 155 all over 2 into 1, right? So that's what we have there. And then you just solve for x, right? So I believe you're going to get 2 answers for x. X is equals to something and x is equal to something, right? And I believe the other answer is going to be a negative answer. And we understand that speed cannot be negative, right? So we're just going to take the positive answer, which I believe is 11,96, right? So let me just verify with my calculator. Right, yes, indeed, it is 11,96, and the other value is negative 12,96, right? So our speed, but speed, right, yeah. So but speed is greater than 0, right? Because if we look at it in physics terms, speed is a scalar quantity. It has no direction. So let's go x, therefore x is equals to 11,96, but our speed is kilometers per hour, right? So yeah, this is it for question 1, I believe. Yeah, so this is it for question 1. And yeah, so if you want me to continue the rest of the paper, just let me know. And then yeah, sure.